I still remember the smell before the mold, that sour tang that rose from soaked canvas when the wind shifted just right. It was December 1941, and Pearl Harbor still glowed faintly in memory, its blackened smoke drifting over the Pacific like a shadow that would never quite leave. But the fire wasn't what haunted us in the War Department. It was the rain, the endless, pitiless Pacific rain that fell on soldiers sleeping in rotting tents thousands of miles away. They'd thought the battle would be with steel and fire. Instead, it was with mildew. The telegrams arrived first: soaked paper, faint type, field hospitals flooded, ammunition spoiled, Marines coughing up blood in the night. Shelters failed, one message said simply. Men sick, equipment destroyed. I saw Brigadier General Eugene Raybould unfold that report with hands that didn't shake, though I could tell he wanted them to. Outside, snow drifted past the windows of Washington. Inside, we were reading about pneumonia, mud, and men sleeping in 3 inches of water. The irony struck him like a physical blow. The world's greatest industrial nation couldn't keep its soldiers dry. Raybould stood before a long table, covered in maps and weather charts, his officers surrounding him in silence. Someone had drawn red circles over the Philippines, Wake Island, and Guadalcanal, places that might as well have been the moon for all the logistics connecting them to us. Every morning, the briefings grew grimmer. Wooden barracks required skilled carpenters, men we didn't have. Lumber was nearly impossible to ship to coral atolls that had no trees, no docks, no roads. Even if we could build them, it would take 6 weeks per structure. 6 weeks we didn't have. And the tents? They disintegrated in 3. The math was merciless. A tent cost $12 and lasted a month. A wooden barrack cost $8,000 and took 6 weeks. Neither could keep 50,000 men alive in the wet furnace of the Pacific. I saw it in Raybould's eyes that morning, that hollow look, when the impossible stops being a problem and becomes a sentence. He tapped the map with the end of his pencil. "We're not fighting the Japanese," he said softly. "We're fighting the weather." Around the room, engineers exchanged helpless glances. Some scribbled numbers, others stared out at the snow. A colonel muttered that Britain had used steel shelters in North Africa, Nissen huts, they called them. Half-cylindrical, corrugated iron, quick to erect. Raybould turned his head sharply. "Get me everything on them," he said. And that was how it began, not with an invention, but with desperation. By the next morning, we had a stack of British blueprints on the table. Peter Nissen's design was clever, an arch of corrugated steel that shrugged off sandstorms, but it wasn't meant for jungles. The panels were too heavy. The ventilation meant for desert, not humidity that could turn a hut into a furnace. Each one needed a foundation, concrete or wood, which brought us right back to square one. Termites would eat the frame before the enemy even saw it. Raybould ran his thumb along the curve of a Nissen drawing, eyes narrowed. "If it worked for them," he said, "it can work for us if we build it right." He looked up then, a man cornered by logistics and weather and time. "I want a structure that ships flat, weighs less than a Jeep, assembles in a day, costs under $1,000, and survives a typhoon." Someone laughed, too nervous to stop themselves. Raybould didn't smile. "And I want 10,000 of them," he added. No one laughed after that. Outside, the snow thickened. Inside, our world became a series of impossible specifications. Every branch of the military received the call. Factories, universities, even naval architecture firms were told to submit designs. And somewhere, in the endless network of teletypes and couriers, the challenge reached a small point on the Rhode Island coast, a place that would soon become legend. But before that miracle, there were weeks of darkness. Every day, more field reports came in the words, "Supply depots flooded, tents destroyed, personnel incapacitated." The army was losing more men to rain than to enemy fire. A medic wrote from the Solomons, "We're not fighting war, we're fighting decay. Boots rot before wounds heal." And somewhere in the back of Raybould's mind, The arithmetic kept multiplying. 2 million men would need shelter across hundreds of islands. 2 million roofs. 2 million lives between storms. I once found him late at night alone in the War Department's map room, his jacket off, his shirt soaked through with sweat. He didn't hear me at first. He was staring at a globe, spinning it slowly under his hand, watching the endless blue of the Pacific roll past. When he finally spoke, it wasn't to me. "We can move mountains," he murmured. "We can build planes that touch the stratosphere, but we can't keep a man dry in the jungle." He turned then, eyes bloodshot but alive with something I hadn't seen in weeks. "So we'll build something the rain can't touch," he said. "Something the wind can't catch, a shelter that wins where men fail." He straightened, buttoned his jacket, and said the words that became an order, a prayer, and eventually a revolution. "Send it to Quonset Point." What followed in the next 72 hours would turn that quiet corner of Rhode Island into the heart of one of the most extraordinary engineering efforts in modern history. But that night, that last quiet night in Washington, Raybould stood at his window, watching the sleet strike the glass like tracer fire. The city's lights blurred into watery halos, and for a moment he looked less like a general and more like what he really was, an engineer trying to solve a problem that could kill millions. He didn't know then that the answer would come in the shape of an arch. He only knew the rain was winning, and that he would not let it win again. By February of 1942, the Pacific had become a graveyard of tents. From the Philippines to New Guinea, our soldiers were sleeping in rags that tore at the first whisper of wind. Every storm flattened an encampment. Every downpour turned foxholes into shallow graves. The radio traffic was full of words like unsustainable, disease, non-operational. It was logistics disguised as tragedy. I was in Washington the morning. The new specifications were issued. One sheet of paper that looked simple enough until you read it twice. A building that weighs less than a jeep. Ships flat, no foundation. One-day assembly, under $1,000. Withstands 140 mph winds, monsoon rain, and enemy bombing. Someone said it sounded like science fiction. Someone else said it sounded like suicide. But the line that mattered most was handwritten at the bottom, in Raybould's tidy script: "Failure will cost lives." That's how the message reached Rhode Island Quonset Point, the Navy's brand-new facility on Narragansett Bay. It was a lonely, wind-scoured patch of coastline where gulls screamed over empty runways and the smell of oil never left your clothes. But it had something no one else did: factories that knew steel-like language, shipyards that understood corrosion, and engineers who were too stubborn to say, impossible. I was among the first to arrive, stepping off the truck into sleet and salt air. The warehouse looked like nothing, just a long rectangle of corrugated tin, but inside it was already alive. Drafting tables stacked with blueprints, typewriters hammering like gunfire, coffee that tasted of rust. And at the center of it all stood Commander John Philip Drosfeld, a thin man with the posture of someone who'd spent his life leaning over drawings. Drosfeld had a habit of talking to himself when he calculated loads. He studied the British Quonset Hut designs and muttered things like, "Genius, but heavy as sin," and "brilliant, if you're building for Scotland." He circled the ventilation specifications in red ink. 2 windows? In the Philippines? They'll cook alive in here. Then, tapping the foundation bolts, he added, "Concrete? You might as well ask for marble floors." But Drosfeld wasn't alone. By the week's end, others had joined him: architects, draftsmen, machinists, and a handful of farm engineers from Pennsylvania who knew more about barns than barracks. And among them, the man who would change everything, Otto Brandenberger of Strand Steel. Otto didn't look like a visionary. He looked like a man who could fix a tractor with his hands tied. When Raybould's letter reached him, he was building prefabricated barns in Ohio, arched roofs that had survived Midwest tornadoes without a single beam snapping. "If my barns can stand up to God," he told the Navy officer who came to fetch him, They'll stand up to Japan. When he arrived at Quonset, he walked straight to the Nissen blueprints, studied them for 5 minutes, and said the words that made every architect in the room go silent. Get rid of the frame. He meant it. The wooden skeleton that gave the Nissen its shape, the frame that every engineer considered indispensable, he wanted gone. No wood, no termites, no rot. The skin is the strength. Drosfeld stared at him like he'd just suggested building a battleship out of glass. That's not architecture, he said flatly. Otto smiled. Then let's stop thinking like architects. At first it felt like madness. Steel was for bridges and ships, not self-supporting shells. The textbooks called it unstable. But war doesn't care about textbooks. The Navy gave us 60 days, 60 to design, prototype, and test a building that had never existed. So, we stopped sleeping. We built by daylight and argued by lamplight. The draftsmen tore through paper faster than the typists could label it. Ideas flew like shrapnel-ventilated arches, bolt patterns, interchangeable panels. Drosfeld paced between tables muttering, "Too heavy, too slow, too complex," while Otto hammered a corrugated sheet with his bare hand to prove how rigid the shape became once curved. Someone brought up the work of an eccentric architect named Buckminster Fuller, a man who'd spent 2 decades dreaming of factory-built homes, houses that could be shipped like automobiles. His Dymaxion designs had been laughed out of every polite room in America, but here, in this desperate winter of war, they suddenly made perfect sense. "Treat buildings like machines," Otto said one night, chalk dust in his hair. "Every bolt numbered, every panel identical. Manufacture them, don't build them." That line became our creed. The Navy christened our effort the Quonset Project after the windswept point we worked on. What they didn't see were the nights when the wind off the bay howled through broken window panes and rattled the steel sheets stacked outside. We ate in shifts, slept in corners, woke to the sound of rivet guns echoing like artillery. I remember one dawn in particular. Snow had blown in through the roof vent, covering the drafting tables. Otto stood over a half-finished model, brushing away frost with his sleeve. He didn't notice me watching him. He just said quietly, "It has to be simple enough for a boy to build with his hands shaking." "Why?" I asked. "Because," he said, eyes still on the curve of steel, "by the time they open the crate, he'll be under fire." There was no argument after that. As the days passed, our sketches turned to mock-ups. The first corrugated panel stood on sawhorses, 6 feet long, light enough for 2 men to carry. The arch held its shape without internal framing, just like Otto promised. It gleamed under the warehouse lights, raw, silver, stubborn. Outside, the snow had turned to rain. The world was still burning, but inside Quonset Point, something extraordinary was being born. Not beauty, not comfort, but survival shaped in steel. We didn't know it yet, but that half-circle of metal would outlive the men who built it. By March 1942, Quonset Point no longer felt like a naval base. It felt like a factory built on adrenaline and borrowed time. The Atlantic winds howled outside, but inside the great warehouse, something like industry mixed with fever. The air was a cocktail of cutting oil, cigarette smoke, and sweat. Pencils snapped. Rivets clattered. The clanging of steel never stopped. 60 days. That was the order. In 60 days we had to design, build, and test a shelter that did not yet exist. Not a sketch, not a scale model. A living structure, one that could stand against typhoons, ship across oceans, and be built by men too exhausted to think straight. We didn't have a choice. Otto Brandenberger divided the room like a general forming battalions. One team calculated aerodynamics and wind load, another tested steel thickness and joint tolerances, a third handled shipping logistics, how to make something 16 feet wide fit into a railway car without special permits. The rest of us floated between them, solving whatever problem screamed loudest. The first rule Otto laid down was simple: build, don't draw. Traditional architecture demanded perfect blueprints before the first nail was driven. Otto had no patience for that. "We don't have weeks for paper," he said. "We have hours for metal." So we built in real time. Someone would sketch a joint in the morning, and by afternoon the shop would have it bent, punched, and ready for testing. By nightfall, a new version would replace it. The floor of the warehouse became a graveyard of failures, bent panels, cracked bolts, and melted rivets that testified to how much we didn't yet know. I remember the smell of the metal shop, the sweet sting of zinc and hot steel, the constant taste of ash in your mouth. We'd work until our eyes blurred, then drink Navy coffee so bitter it could peel paint. Some nights, we slept on cots against the walls, waking to the sound of drills and laughter that bordered on hysteria. Still, the design took shape, one sleepless miracle at a time. The breakthrough came when the engineers realized the arch itself could be its own skeleton. A perfect semicircle, 8 feet tall, 16 feet wide, the curve was its strength. The corrugated ridges that ran the length of each panel acted like dozens of tiny I-beams, turning what looked flimsy into something astonishingly strong. We tested the first arc by setting it on sawhorses and loading it with sandbags. 200 pounds, 400, 800. The steel flexed, but didn't buckle. Otto ran his fingers along the top, nodding once. "It's not a building," he said quietly. "It's a spring." The details began to align like gears. Each section would be 20 feet long, bolted end to form a structure 48 feet long enough for 36 men or a field office or a storage depot. The bolts, 3/4-inch steel, spaced every 6 inches, would make the entire arch act as one continuous compression ring. But the floor nearly broke us. We had tried wood at first. It was familiar, comforting. But it added weight, slowed assembly, and would rot in the first monsoon. The test hut's floorboards swelled after 2 nights of fog, and when Otto saw the black mold blooming in the corners, he cursed loud enough to wake the bay. "Rip it out," he said. "If the earth wants to be the floor, let it." That single decision changed everything. Without a floor, the structure lost 1,200 pounds. The assembly time dropped from 14 hours to 8. It became lighter, faster, cheaper, and, in Otto's words, honest. By the 40th day, the Quonset Point hut looked less like a prototype and more like an inevitability. When we finally stood the first full structure, it gleamed under the warehouse lamps like the inside of a bell. The air smelled of ozone and hot steel. 6 sailors, volunteers from the base, had assembled it in 14 hours using nothing but wrenches and a hammer. None of them had seen the design before that morning. When the last bolt went in, we stepped back and just stared. It wasn't beautiful, it wasn't meant to be. But in that moment, it looked like hope made tangible, smooth, curved, self-contained, a structure that needed no explanation. We called it simply the hut. The next day, the Navy sent in the testers. They arrived with clipboards, equations, and a skepticism you could feel from across the room. They measured every angle, recorded every load, every deflection. Then they told us what was coming: a trial by storm. That March, a nor'easter swept down the coast with 75-mile winds and snow that fell sideways. The test hut stood at the edge of the runway, instrumented with strain gauges and pressure meters, while the storm roared around it like a living thing. We watched from the control shed, breath fogging the glass. At the height of the wind, the hut flexed no more than 2 inches. When the storm passed, the steel sprang back to shape, every bolt still tight, no leaks, no failures. Someone started to laugh, then another. Otto just stood there, silent, the snow plastered against his coat. He brushed his glove along the arch and said, "She breathes, but she doesn't break." It should have ended there, but it didn't, because Rhode Island was not the Pacific. Wind was only one enemy. The next would be heat, salt, fungus, and decay. The Navy packed the prototype into crates and shipped it to the Panama Canal Zone, where humidity turned steel into rust within weeks. 6 months later, the report came back. The structure still stood, but the inside had rained. Condensation dripped from the ceiling like a leaky faucet, pooling on bunks, soaking papers, rusting tools. So we went back to the drawing board this time, adding louvers along the ridge, vents at each end, small openings to let the hot air escape. It added $47 per unit, but it made the difference between a steel coffin and a livable shelter. By June 10, 1942, the final prototype was ready. 96 corrugated steel panels, each under 50 pounds. Total weight, 9,000 pounds. Total materials cost, $1,394. The Quonset Hut was real. We didn't cheer when it was approved. We were too tired, too aware of what came next. 10,000 orders, millions of square feet of steel, a war still raging. But that night, as the sun fell over Narragansett Bay, I walked back through the silent warehouse. The floor was littered with bolts and coffee cups, the smell of hot metal still in the air. And there, against the far wall, the finished hut gleamed like a full moon, simple, strong, utterly human. In 60 days we had built not just a building, but a promise that a man would never again face the rain unprotected. The hut looked so simple when it finally stood there, glinting under the Rhode Island sun, just a curved shell of corrugated steel. But simplicity, we would learn, is a dangerous illusion. You don't know if a design truly lives until you watch it suffer. That summer, we put the Quonset Hut through hell. The Navy engineers arrived with clipboards, anemometers, and that quiet skepticism that only men of equations can carry. They set up the test site along the coast at Davisville, open to the Atlantic winds, where gales from Greenland barreled through without mercy. They wired the hut with strain gauges and barometers, measuring every heartbeat of the steel, and then they waited for nature to try and kill it. When the first nor'easter rolled in, the sky turned the color of pewter and the air thickened with sleet. We huddled inside the observation shack as 75-mile-an-hour gusts screamed across the bay. The hut bowed under the pressure, its steel ribs flexing like the lungs of a living thing. Snow piled high against its sides. The instruments fluttered madly, the wind howled through the vents, and for a moment I thought we'd built a coffin after all. But when the storm passed, the hut stood untouched. Not a bolt loosened, not a panel warped. Only streaks of sea salt traced the curves like battle scars. Otto brushed his fingers along the metal and said, almost reverently, "It breathes, but it remembers its shape." We sent our data to Washington that night. Within a week, new orders came, tropical testing next. The Navy shipped 1 unit south to the Panama Canal Zone, a place so hot and wet, the air itself seemed to rot metal, 85% humidity, temperatures in the 90s, jungle sounds that never stopped. 6 months later, the report came back. The hut still stood strong, unbent, the galvanization barely corroded, but it had a new enemy. Inside, it rained. When the nights cooled, condensation formed on the inner walls, running down in steady drips. Soldiers woke up soaked, their bedding wet as if they'd been caught in a downpour. The tropical air met the cooler steel and turned the inside of the shelter into its own weather system. The engineers called it internal precipitation. We called it humiliation. For a week we sat around the table in silence, staring at the reports. Then Drosfeld picked up a pencil and said, "If we can't stop the heat, we can move the air." That's how the louvers were born. Narrow vents along the ridge and at each end wall, cut to bleed off hot air and draw in cool drafts. We tested them with smoke pellets, watching the thin trails swirl up through the vents like ghosts escaping. It worked. The air moved. The heat fled. Each vent added $47 to the cost, but Otto didn't blink. $47, he said, is cheaper than a funeral. Our next problem was anchoring. Rhode Island soil was firm. Pacific coral was not. How do you keep 9,000 pounds of curved steel from rolling away when a typhoon hits? Concrete foundations were impossible. Time and materials made them fantasy. We found the answer, strangely enough, in tent design. Steel stakes driven deep, tied with tension cables that held the base like harp strings. The hut didn't resist the wind through brute force. It sang with it. It flexed, bent, and returned to shape a building designed to dance instead of fight. When we tested this setup in the field, we watched the cables hum under load, vibrating like the strings of a cello. Even in the heaviest gusts, the arch didn't fail. The force flowed around it, like water around a stone. That night, when the wind finally died, Otto stood by the doorway and whispered, "The shape is wiser than we are." By June 1942, the final numbers spoke louder than we ever could. 9,000 pounds total weight. 96 corrugated panels, each under 50 pounds. 720 square feet of enclosed space. Materials cost $1,394. Assembly time, 8 hours. The Navy signed the approval 2 days later. The War Production Board sent out the telegrams, "Mass production authorized." But none of us celebrated. Not yet. We knew the real tests were coming not in Rhode Island storms or Panama humidity, but in places where the wind carried shrapnel and the rain smelled of salt and blood. The Pacific awaited. That night I walked back down to the shore. The moon hung low, silvering the curve of the first finished hut. It looked almost organic, like a seashell left by some giant tide. I ran my hand along its cool surface, and for the first time, I realized what we had truly built. Not just shelter, not just steel, but an idea that something could be both simple and unbreakable. That strength didn't have to roar. It could whisper through a curve. The waves rolled in and hissed against the docks. Somewhere in the distance a freighter horn moaned, and I thought of the men it would soon carry, the builders, the fighters, the ones who'd sleep under these arched roofs while the world around them burned. They didn't know our names, but they would trust our work. And that, I remember thinking, was enough. By the end of that summer, the blueprints we'd drafted in a freezing Rhode Island hangar had begun their transformation into an industrial storm. The numbers still stagger me. 10 factories, 30,000 workers, and a production schedule that didn't stop even when the clocks struck midnight. America had learned how to build faster than it could breathe. The first coils of steel arrived by train, massive, 4-foot-wide ribbons wound tight like artillery shells. When they unspooled across the floor of the rolling mills, they screamed with the sound of power. The corrugating machines bit into them, folding the flat steel into ridges, exactly 2.67 inches apart. The pattern looked simple, waves of metal repeating like ripples on water, but every fold made the sheet stronger, more stubborn, less human. Those ridges were what made the Quonset Hut immortal. A straight sheet of metal could tear like paper, but fold it and it becomes a muscle. In the galvanizing rooms, the air shimmered with heat. Workers in heavy aprons dipped the panels into vats of molten zinc, heated to 850 degrees Fahrenheit. The smell was chemical and sharp, like burnt coins. The zinc would sacrifice itself to corrosion before the steel beneath it could rust. I remember one foreman saying, "These huts will outlive us, boys," and no one laughed. Each factory became a small war of its own. Strand Steel in Philadelphia converted its barns into assembly lines. Great Lakes Steel fed 2 entire mills with nothing but Quonset orders. The Fuller Construction Company took over an abandoned automobile plant in Chicago and turned it into a hive of hammers, bolts, and flame. When the war planners saw the numbers 1,500 huts per week, then 3,000, then 8,000, they called it miraculous. We called it the new front line. What amazed me most wasn't the building of the huts, but how precisely we learned to move them. Each structure had to be flat-packed into one rail car. 96 nested panels, each curved to rest within the next like metal petals. The end walls plywood, with pre-cut door and window frames, slid between the steel stacks. Every bolt, nut, and washer was boxed into a single wooden crate that included illustrated assembly guides drawn so clearly a man who couldn't read English could still build the whole thing in a day. Every crate that left Philadelphia carried a strange kind of heartbeat. You could stand beside the tracks and watch them thunder westward, trains bound for the Pacific ports, each box holding a promise of shelter for men who hadn't seen dry socks in weeks. We joked about it sometimes. "Our army doesn't march on stomachs anymore," one welder said. "It marches on bolts." He wasn't wrong. At the ports, San Francisco, San Diego, Seattle, the huts waited alongside tanks and jeeps, their metal skins catching the California sun. Liberty ships groaned under the weight as cranes swung the crates aboard, lowering them into the holds with the precision of surgeons. One ship could carry 200 huts shelter for 7,000 men and still have room for rations and ammunition. The logistics officers tracked every bolt, every shipment. If one crate went missing, it wasn't just inventory, it was 2 squads without a roof when the rain came. The first huts arrived at Guadalcanal in August 1942. The beach was a strip of ash and coral, the air heavy with gunpowder and humidity. Japanese bombers still came daily, strafing the palm trees and whatever moved beneath them. The Marines unloaded the steel panels with trembling hands, working by instinct and adrenaline. The illustrated instructions were smeared with rain, but they followed them anyway. 6 men, 8 hours. No foundation, no wood, no carpenter, just bolts and courage. By dusk, the first hut stood a silver shell in a world of mud and smoke. When night came, the bombers returned. One 500-pound bomb detonated 40 yards from a hut full of aviation mechanics. The blast wave tore palm trees from the ground, shredded tents into rags, and left the air full of dust and silence. When the smoke cleared, the hut was still standing. The men inside stumbled out, covered in dirt but alive. Later, when a war correspondent asked one of them what it had felt like, he said, "It sounded like God exhaling. Then we realized we were still here." That line made it back to Washington. Raybould read it aloud in a briefing, and no one spoke for a long time afterward. Of course, not every test came from bombs. The Pacific itself was an enemy, relentless, wet, and full of decay. Within 2 weeks, the first huts began to show streaks of red rust where ungalvanized bolts had been used. The salt air turned steel to lace. Mold crawled over everything that held moisture. Marines began cutting extra ventilation holes with tin snips, ignoring the blueprints. When reports reached us, Otto didn't flinch. "If they cut it open," he said, "it means they want to live in it." We redesigned again. Every fastener galvanized, every vent widened, every louver expanded to let the air flow faster. The huts that followed were better, tougher, more forgiving. By the end of 1943, our factory lines were running 24 hours a day. The cost per unit hadn't changed, still $1,394, but the efficiency was beyond anything America had seen. A single hut could house 36 men, be assembled in 8 hours, and last for years. I began to think of them as soldiers themselves, quiet, curved soldiers who fought storms instead of armies. They didn't fire bullets, but they saved lives. One night, walking past the assembly floor in Chicago, I paused by a half-finished hut resting on its side. Under the fluorescent lights, the corrugations looked like the ribs of a massive creature, something ancient and alive. I placed my palm against the cool steel and felt the hum of the factory vibrating through it. In that vibration, I could almost hear it breathing. I thought of the Marines at Guadalcanal, the way they must have leaned against those same ribs as rain battered the roof. I thought of Otto's hands, raw from steel edges, and Raybould's voice when he said, "We were fighting the weather." And I realized that we'd done more than build a shelter. We'd built proof that human ingenuity could turn desperation into endurance and steel into mercy. The huts went everywhere the war went. That was the first thing I noticed when the reports began arriving from the edges of the map. From the jungles of Guadalcanal to the volcanic sand of Iwo Jima, from the wind-lashed Aleutians to the bombed streets of Palermo, that curved line of corrugated steel appeared like a signature proof that we were there, that we endured. They called them tin tunnels, steel tents, Quonsets, but to the men inside, they were home. In August 1942, at Henderson Field, the air smelled of oil and rot. The temperature clawed at 95 degrees even in the shade. Japanese bombers still came at dusk, painting the horizon with fire. On the beach, a handful of Marines bolted the last panels into place while sirens wailed in the distance. The steel burned their hands, but they didn't stop. By the time the sun dipped behind the jungle, 10 huts stood where that morning there had been nothing but cratered sand. 3 days later, the test came. A bomb dropped too close. The blast flattened palms, shredded tents, and filled the air with dirt thick enough to choke on. When the dust settled, the Quonsets were still standing. Panels dented, doors hanging, but the arches unbroken. One corporal wrote in his letter home, "The huts bent like they were breathing. When the shock wave hit, the roof rippled, and then it went still, like it was listening." We read that line aloud in Rhode Island and didn't speak for a while. But war isn't sentimental. The Pacific hated steel as much as it hated flesh. Within weeks, salt air ate through the bolts, leaving red streaks like blood down the sides. Fungus spread on every surface that stayed damp for more than an hour. The men inside hacked extra vents with bayonets, propped open doors, and prayed for air. Their ingenuity saved them as much as ours did. Those field modifications came back to us in grease-stained letters. We copied them straight into the blueprints. Bigger louvers, more galvanized fasteners. We didn't argue with soldiers who had survived a monsoon, and the results spoke. When Typhoon Cobra struck the Philippines in December 1944, with winds of 140 miles an hour, 80% of the base at Tacloban vanished, wooden buildings exploded, concrete cracked, but 39 out of 43 Quonsets stood untouched. The report from the commander was only 5 words long. Quonset Hut survived. Everything else gone. The same year, halfway across the world, another set of huts faced the opposite nightmare. In the Aleutian Islands, Alaska, winter was an executioner. The temperature dropped to 40 below. The wind a constant 100 miles an hour. Steel became brittle. Bolts snapped like twigs. Early shipments cracked clean through at the bolt holes, the panels splitting under stress. When we read the first field reports, Attu drew a heavy line under one phrase, metal fracture due to cold. Within days, we switched to cold-rolled steel and added rubber gaskets to every joint. The next batch held. The huts groaned under the storms, but they did not shatter. Soldiers there wrote that the noise was like sleeping inside a drum being played by God. They stuffed insulation between double walls, wrapped the roofs in tar paper, and for the first time in months, could feel warmth again. It wasn't comfort, but it was survival. Europe brought yet another trial. In Sicily, a Quonset pressed into service as an ammunition store took a direct hit from a German 88mm shell. The explosion turned everything inside to fire, yet when the flames cleared, the arch still stood twisted but intact. The blast had vented outward through the curve instead of collapsing the structure. The engineers who examined the wreckage wrote that a rectangular building would have killed every man within 50 feet. The hut's arch had absorbed the shock, channeling it into the ground, the way a bridge absorbs weight. It wasn't designed for war, but somehow it had learned its language. Everywhere the huts went, they gathered stories. On Tarawa, Marines painted shark teeth on the end walls. In New Guinea, pilots slept beneath arches that glowed dull red from the sunset. In Burma, they stood on stilts over swamps. In the Aleutians, they half buried them in snowbanks like igloos made of armor. We kept building, shipping, adapting steel following soldiers the way shadow follows light. By mid-1944, over 160,000 Quonsets had been deployed. 6 million men sheltered under their arches. Sometimes, reading the reports, I felt a strange pride tinged with sorrow. The huts had become more than engineering, they were part of the war's anatomy, silent companions to courage. At Quonset Point, we'd done what no one believed possible, turned desperation into durability. But even then, none of us imagined what would happen when the shooting stopped. Because the war would end, but the huts wouldn't. The steel would keep standing long after the guns went quiet. May 1945. The radios were full of church bells and static, the sound of victory mixed with exhaustion. Men walked home in silence through streets filled with ticker tape and ghosts. The war was over, but the huts, the strange curved shelters born in panic and welded in haste, refused to end with it. Across 6 continents, they stood like fossils of urgency, 170,000 Quonset huts, gleaming in the morning light, each one a small echo of the war that had built it. Some still smelled of salt and sweat, some were dented from shrapnel, some were half buried in coral sand, and the military, suddenly faced with peace, had no idea what to do with them. At first, they talked about demolition, scrap the metal, melt it into cars, rebuild the world. But then came the numbers, 2 million returning soldiers. One country without enough roofs to hold them. Lumber was scarce, contractors scarcer still. Families slept in cars, in barns, in warehouses converted into dormitories. It was Raybould himself who said what everyone was thinking: why destroy what's already shelter? The War Assets Administration began selling surplus huts at liquidation prices $1,000 for a full kit, sometimes less if you hauled it yourself. Veterans lined up outside government depots like it was Christmas. They called it the cheapest house in America. In Los Angeles, a sprawling field of huts became Roger Young Village, 750 families, living under arches that once faced the Pacific's typhoons. Children rode bicycles down the curved corridors between units, their laughter bouncing off steel walls that had once echoed with shell fire. In New Jersey and Oregon, entire neighborhoods rose out of surplus crates, the air filled with the sound of hammers and the smell of hope. Some people painted their huts pastel pinks and yellows, softening the war from memory. Others added porches and wooden facades, hiding the military bones beneath floral curtains and potted plants. Inside, the acoustics were odd voices curved back at you, but for the first time, the echo didn't sound like fear. By 1946, you could find Quonsets in every corner of the country. Near universities, they sprouted into makeshift towns called vetvilles, filled with students studying under roofs that had survived bomb blasts. Professors lectured in what used to be supply huts. Young mothers hung laundry between arches that once sheltered rifles. School boards bought them too. The baby boom had begun, and classrooms were running out of walls. A single hut could hold 30 children, a teacher, and a blackboard. The paint flaked, the floors creaked, but the lessons stuck. In those round rooms, the generation that would walk on the moon learned to count. Even churches borrowed the design. In Levittown, Pennsylvania, a congregation raised their first Quonset chapel in a single weekend. They called it the Tin Tabernacle. The roof sang during rainstorms, but the pastor said the sound reminded him of wartime hymns, steady, metallic, unbreakable. For 20 years, the huts refused to fade. They stored grain in Kansas, housed artists in New York, and became workshops, garages, grocery stores, and dance halls. They were so common that no one thought of them as remarkable anymore, just part of the American landscape, curved like a horizon line. Yet they were never beautiful, not in the way architecture students understood beauty. They were plain, repetitive, utilitarian, and maybe that's why they lasted. Because beauty wasn't what people needed. They needed shelter that didn't lie, that didn't collapse, that kept its promise even after the war's noise had gone quiet. I used to drive past one near Providence, a small one, rust streaking down its sides, weeds growing at its base. Someone had turned it into a mechanic's shop. The paint on the sign above the door was faded, but the words were still legible. Open since 1946. That's when I understood what we had built. Not a temporary solution, not wartime ingenuity, but something eternal in its simplicity, an arch that could carry weight far beyond what we'd imagined. And though we didn't know it then, that same shape would one day rise again in disaster zones, in refugee camps, even on the red dust of Mars. The same geometry, the same principle. Strength through curve, survival through simplicity. The war had ended, but the huts had not. They had become something more, proof that when humanity is cornered, its best ideas don't fade with the fighting. They adapt, evolve, and shelter the generations that come after. I sometimes think about that winter night in Washington, when Raybould whispered that we were fighting the weather. I wish he could have seen how far that fight went, how many lives that curve would touch. Because in the end, the Quonset wasn't just steel and bolts, it was endurance, bent into shape. Time has a way of erasing urgency, but not shape. Long after the battles faded into textbooks, the curve remained. Decades passed, and the huts we built in fear began to reappear in compassion. Different materials, different names, but always the same arch, the same quiet defiance against chaos. I remember the first time I saw one again, years after the war. It was 2010, on a television screen showing the aftermath of an earthquake in Haiti. Rubble stretched as far as the camera could see, collapsed homes, concrete dust, the silent grief of a broken city. And in the middle of it all stood a few arched shelters, gleaming under the Caribbean sun. Steel frames, quick to assemble, curved like the ones we'd built at Quonset Point 70 years earlier. They called them RHUs, refugee housing units. But I recognized the lineage instantly. Prefabricated panels, self-supporting arch, light enough for 2 people to lift. They were our huts, reborn in plastic and composite instead of galvanized steel. The same principle, the same mercy, speed, strength, simplicity. That was when I realized the Quonset Hut had never died. It had only evolved. In the decades after the war, architects tried to forget it. They called it primitive, utilitarian, unbeautiful. But the storms never forgot, and neither did necessity. When Hurricane Katrina tore through the Gulf Coast in 2005, researchers studying what survived discovered something uncanny. The curved structures stood while the squares collapsed. Rectangular houses had their roofs torn off, their walls peeled like fruit skin. But the few arched steel buildings left behind, most of them old Quonsets, repurposed as storage, remained intact. It was physics, not nostalgia, that saved them. Wind slides off curves. It destroys corners. We'd known that in 1942, though we never called it poetry. Now they call it aerodynamic architecture. I call it remembering. The modern world found new ways to dress the same skeleton. Tiny home builders used the design for eco-cabins. Farmers resurrected it for greenhouses. Architects rediscovered the beauty and function and began sketching arch-roofed modern retreats with floor-to-ceiling glass. Some cost $300 a square foot, sold as luxury. I smiled the first time I saw one in a magazine. It was still the same soul, just polished for comfort. And still, the military used them too. In Afghanistan and Iraq, you could see them newer, lighter, built from aluminum alloy and Kevlar panels. Helicopters dropped them in pieces. Soldiers assembled them in an hour. Some had air conditioning, insulation, satellite links. But if you stripped them to their bones, the geometry was identical. The curve that could bend without breaking. I sometimes wonder if Otto would have smiled, seeing one of those huts in the desert heat. "See?" he'd have said. "The shape still works." But perhaps the most humbling echo comes from beyond Earth. In laboratories and design offices across NASA and SpaceX, engineers are once again sketching arched structures, modular habitats for Mars, sealed against vacuum and dust storms. They face the same challenge we did in 1942. How to shelter human life in an unforgiving world with limited tools, limited time, and no margin for failure. And their answer, prefabricated, curved, self-supporting, could have been drawn on our old drafting tables. The thought of it still stuns me. That something we built for mud and monsoon might one day stand under alien skies. That a shape first meant to survive bombs might cradle the first seeds of another civilization. Looking back, I think what made the Quonset remarkable wasn't its steel, or its bolts, or even its design. It was its humility. It never tried to be anything more than what it was: enough. Enough to stand through storms, enough to protect a man's sleep, enough to give structure to survival. The curve was never just geometry. It was grace, the smallest, simplest line that could hold back chaos. I drive sometimes past an old airfield near Providence, where a few huts still stand, their zinc long gone to rust, their arches half buried in weeds. The wind moves through their vents with a low hum, and the sound always takes me back to that winter in Washington. The maps, the rain, Raybold's voice saying, "We're fighting the weather." He didn't know then that we'd end up fighting time too, and somehow the huts would win both battles. Because the world keeps changing its wars, its disasters, its frontiers, but the need never does. The need to build something that lasts, something that bends without breaking. And every time I see that curve against a new horizon, whether it's a refugee camp, a hurricane zone, or a red planet waiting for its first dawn, I can almost hear the echo of steel and storm and stubborn hope. We built them so men could survive the war. We didn't know we were building something that would outlive the century.